Okay, in our last session, our last lesson, last video, last whatever, we talked about measures of central tendency, mean, median, and mode. And those are the kinds of things to where we typically report one depending on the distribution. I use the word distribution in a particular way, not a real technical way, but when I say distribution, the word distribution essentially means a set of numbers. And so sets of numbers have measures of central tendency, which include mean, median, and mode. So let's look at an example or two, and again, be patient with me while I try to switch over and show you something. I'll try to figure out how to share this just right. Okay. Okay, can everyone see me down in the corner and a blank whiteboard space up in the main body of the, good, thank you. All right, let me give you a couple examples of a distribution. Two examples in particular. Here's the first example of the distribution. I'm going to call this distribution, I'm going to call very unimaginatively X. So my X distribution is going to be 90, 90, 90, 90, and 90. Okay, what observations might you make about that distribution that has an N of 5? Remember, N means the number of things you have there. We've got 5 of them. An N of 5, and every one of them is 90. What kind of observations might you make in terms of measures of central tendency? What other observations might you make in terms of measures of central tendency? Mean, median, and mode. The what? Everything's got to be 90. Certainly the mean, the average is 90. The mode is 90. The median, the middle number is 90. There's not a lot of variability. Remember I used the word variability last week and talked about a variable being something that has a changing value from one situation to the other. When I use the word variability in this context, it also means changing. There's not much change here from one to the other. Matter of fact, there's not any at all. So there's really no variability. Nothing varies from one number to the other. Let me give you a second distribution I will so creatively call the Y distribution. If I've done this right, 89, 92, 89, 93, 87. Now what observations about measures of central tendency might you make? Mean, median, and mode. You do a little ciphering in your head. What's the mean? And again, keep in mind that mean is the most common, the most used measure of central tendency. The mean is what? Oh, have I done that wrong? I don't think I have. Thank you. So the mean of X, and we'll call it X bar, is 90. What is the mean of Y, or Y bar? You got your slide rules out. Okay, it is also, as you say, 90. So both distributions have a mean of 90. And I could ask you about the mode and median of Y. You'll have to kind of mentally rearrange these things. The mode's easy to see. What's the mode of distribution Y? Keeping in mind the mode is the one that shows up most often. So the mode's 89. And what is the median? And that's where you have to kind of mentally rearrange these things. But the median is also 89. Now, what observations might you have about the variability between the two distributions, x and y? We already said that there's not any variability in x. Is there variability in y? Yeah, because there's change from one value to the next. So there is variability in y. So we have to have some measures or some measure to describe that variability. Now, typically when we describe a distribution, we give two pieces of information, usually the mean and something that tells you about the variability. Now, the simplest way of measuring variability, you ready for your next formula? Okay, next formula, here you go. R equals H minus L. R stands for the range. So the range is H minus L. What do you suppose H and L stand for? High minus low. So in distribution X, high is 90, the low is 90. The range is 0. It doesn't get any off of the score of 90. But for distribution Y, so I'm going to call the R, I'll call it R sub Y. The high is 93. Minus the low is 87. So the range is 6. A very simple way to measure variability. It's very simple and it's very inadequate. Inadequate. It's a lousy way to do it. Because, a couple of reasons. One is that, and this is kind of like those advantages and disadvantages of a measure of central tendency. This is going to sound like one of those. One disadvantage of doing it this way is that it only takes into account two numbers, the high and the low. It doesn't matter what the different numbers are. What if my high was, what if I had another number here that was 1,000? What would that do to the range? It'd be 1,000 minus 87, so that would be a really, really artificially large range, where most of the distribution is on the lower end of that range. So it's just like an extreme, what do we call the, what's the name of the things that are extremely high or extremely low measures that pull the mean way in that direction? An outlier. An outlier, just like it artificially inflates the mean, an outlier artificially inflates the range. So 1,000 minus 87 would not be a really good range because it's misleading. So it doesn't really work the way we need for it to work. All right, so let's think of maybe something else we could do. So is everybody keeping up with these complicated formulas? Okay with that? So far, so good? Okay, hang on a second here. Let's see. Wouldn't it be fair? Shouldn't every number be considered when we're talking about the variability? Because doesn't every number impact it some, just like every number impacts the mean? Where that's not true of the median or mode. Certainly not true of the range. So we have to have a way to account or consider every number, but in a fair and not an artificially inflating way. So let's look at this distribution again, and let's do a couple things with the numbers. Give me a second to clear this off and remember what numbers I'm working with here. I'm still going to call this the, okay, well, I'll just, 89, 92. I need to hang on. Is it okay if I change the name of this to X since we're not going to have a separate X anymore? Okay, so 89, 92, 89, 93, and 87. And we said the mean is 90. Let's come on down. Okay. Now, the mean is 90, but none of our numbers are 90. They're all a little above or a little below. So what I want to do is, and that's what variation means, how it varies from the mean. Think of mean, as I said last time, think of mean as sort of the balance point, the center of gravity. Some are a little heavier than that, some are a little lighter than that. So let's look at each one of these numbers, and let's see how far away from the mean each number is. So my next column is going to be x minus x bar. X bar being 90. So 89 minus 90 is negative 1. That means it's 1 below the mean. 92 minus 90 is 2. 89, again, is still 1 below the mean. 93 is 3 above the mean. 87 is 3 below the mean. So what we'll call those the deviation scores. Now, one other thing to make life complicated, and because statisticians, as I've said before, are just lazy people, this is too much to write x minus x bar. That's just too much trouble. Well, I'm ambitious. I'm going to stick with that. But I will tell you that sometimes you'll see it abbreviated as sort of a small, leave yourself much room, small kind of sort of curly QX. That means x minus x bar. Again, just a lazy way to say that. It's pretty pathetic when you can't write x minus x bar, but that's the way we are. So I've got a column. There are my mean deviation scores. Why don't I just take all the deviation scores and add them up together and let that be my measure of deviation, or my measure of variability? What happens when I add all these together? I'll get 0. Every time I'm going to get 0. So my total of these is 0. That's not very helpful, especially if it happens every time. But just for the sake of, again, our notation, our nomenclature stuff, the sum of those, remember the word sum, the sum of those x minus x bar deviation scores, how do we write sum? Said that with that uppercase sigma. So sum sigma of x minus x bar. That is always 0. It's not helpful other than it's kind of a good check. So if you don't get 0, you've done something wrong. Now, I've made this problem up to where the numbers are really nice and neat and easy to work with. In reality, you might have some kind of long decimal mean, which your deviation scores are going to be. You're going to have to round off to 2 or 3 decimal places. So you might not get exactly 0. You might get a little above or a tiny bit below because of round off error. Now, that's not very helpful, but we've got a couple of options to deal with that. The problem in getting that 0 as a sum, the sigma of x minus x bar, is those pesky negative numbers. Now, there are a couple of ways mathematically to deal with negative numbers and get rid of them. Can you think what they might be? I can think of 2. One of them we're going to use. The one we're not going to use is absolute value. It means you just whack the negative off. That's not going to. What's another mathematical thing you can do to any number and you won't get a negative number? I'm going to take each of these numbers and square them. Because if you square anything, you don't get a negative number. Oh, and by the way, the lazy way of writing it is the little curly QX squared. Okay, so I'm going to square each of these. So negative 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. 3 times 3 is 9. Negative 3 times negative 3 is 9. So now I've got, let me take a deep breath before I say this, the squares of the deviation scores. And just like I did last column for fun, I'm going to add all these together. And I get 24. So that is, another deep breath, that is the sum of the squares of the deviation scores. So the sum, sigma, of x minus x bar squared, in our case, is equal to 24. Now, so that is the sum of the squares of the deviation scores. And that's for how many scores altogether? What's our n? 5. So what if I take the average of those? So my average of the sum of the squares of the deviation scores, that's going to be 24 divided by 5, which is 4.8. Now I've got to do one more thing, or actually more properly phrase. Cheryl, you're on the right track, but the wrong direction. I've got to undo something. What did I do? I need to undo. I need to unsquare it. So that means to square root it. So the square root of 4.8, here's where I'm going to get a nasty decimal number. So my square root of 4.8, it's wrong, calendar, wrong, calculator, approximately 2.19. .19 is called the standard deviation. The standard deviation is the typical way we measure variability. That's the way we report it. Now let's go back and see what we've done. So when we built this thing, we started with an X. And we subtracted the mean. We squared that. We divided it by n. And then we took the square root of it. And that is the formula for standard deviation. Now, 2 observations. If I had given you that to begin with, you would have thrown stuff at me, walked out, logged off the computers probably, because if I said we're going to do this, you would have said, well, I don't want to do that. But I think by building up to it makes sense. Now, notice the formula. Never, ever, ever think about it again, because speaking of statisticians being lazy, I got an easy way to do this. We're going to make somebody else do it for us. I'll show you how to do that in just a minute. I do need to make one adjustment. What do you notice in my formula? What do you notice in my formula with regards to populations and sample? I'm using a big N. What does that mean? That's the formula for standard deviation for a population. Usually we don't have a population. Usually we have a sample. So I need to make one very, very, very slight modification to adjust this to be the formula for the standard deviation for the sample. And that is simply two things. Instead of using N, big N, I'm going to use a small n, if I can write it. And one more little thing, because the sample typically doesn't look exactly like the population, I've got to build in a little wiggle room, a little margin of error. So instead of just going from big N to small n, I'm going to divide not by n, but by n minus 1. That'll give us a little larger number because I'm dividing by a smaller number, so you're going to get a larger quotient and a larger number to take the square root of. Now, the other thing, and again, we typically use standard deviation. Well, let's go ahead and apply this to our previous formula. So instead of dividing by, this doesn't help. Instead of, let's see if I can use the cursor here. There it is. Instead of dividing by 5, what do I really need to divide by? If this were a sample, I need to divide by 4. And I'm going to get not 4.8, but I'm going to get 6. So it would be 6 that I'm taking the square root of, which is not 2.19, but it's rather about 2.45. See how the number gets a little larger when we're using the sample formula, like we said it would, rather than the population formula. Okay, so I show you this formula, and I walk through it because it's important to know how this works, because these same kinds of concepts are going to show up later, and that's going to be the why of why you do some things that you do. Now, one more thing before I show you the easy way of this. Sometimes formulas ask not for the standard deviation, but they ask for the variance. And variance actually makes it sound like it's the word term makes more sense. The variance is very simple. The variance is the number that you get before you take the square root. So in our case, 6 is the variance. Now, sometimes you'll see formulas in textbooks or wherever. You'll see standard deviation squared. That's the variance. Variance and standard deviation are kind of like, sort of like radius and diameter, where if you know one, you can get the other. So, if the variance is 9, what's the standard deviation? If the variance is 9, what's the standard deviation? I'm trying to watch both places. Yeah, that's correct. Standard deviation is 3. If the standard deviation is 4, what's the variance? Say again? Nope, other way around. Standard deviation is 4. That's after you take 616. So you square it. So take the square root of the variance to get the standard deviation, square the standard deviation to get the variance. If the variance is 25, what's the standard deviation? 5. If the standard deviation is Can't do this in my head. There it is. If the standard deviation is 16, what's the variance? Tricked you. 256. Just because it's a nice, neat square number doesn't mean you take the square root of it. Okay, so take the square root of the variance to get the standard deviation. Square the standard deviation to get the variance. One more thing in terms of nomenclature. Sometimes you'll see the standard deviation referred to like that. That's actually a lowercase sigma. That means standard deviation. If it was squared, it would be the variance. And you'll see that in formulas too. But it doesn't matter because if it tells you to square it, you square it. Let's do what it says. Okay. So, when we describe a distribution, let's describe this X distribution, I would give two pieces of information. I would say actually three pieces. I have a distribution that has a mean of 90 and a standard deviation of 2.45. Oh, n is equal to 5. Sometimes you get usually the n too. N is 5, x bar is 90, standard deviation is 2.45. Questions, thoughts, comments? Okay. All right, let me just show you something. I had a question before class started. We're going to do SPSS tonight, and I lied and said no. Actually, you're not. But I want you to watch me do something. Normally, when I use SPSS, I will want you to follow along using your own SPSS. But in this case, just watch me. You'll get plenty of opportunity to have your hands on this stuff. But just watch me for now. And let me show you how to do what I've taken about 30 minutes to do. Let me show you how to do it in about 30 seconds. If you already have it, some of you did. I know some of you are still working on it. If you have it, go ahead and feel free to follow along with it and do your own. It will help in the long run, but you don't really need to. I just want to kind of show off and show you how something works. If I can find it, there it is. I'm calling up SPSS. I'm just opening it. I say that I am. Maybe I am. Maybe I'm not. There it is. Okay, when I open up SPSS, I get this window that says, what do you want to do? Do you want to open something? I'm just going to say either OK or cancel. I want to get to this. Well, I don't want to get to that part. I want to get to this part. Let me make this a little larger. Okay. This is a blank SPSS document. Remember that SPSS stands for Statistical Package for Social Sciences. It looks like it's got rows and columns. Right now they're blanks. It looks kind of like a big spreadsheet, and that's pretty much what it is. Now at the bottom you will notice, and I think the cursor shows up on your, is the cursor showing up where I'm pointing back and forth on your screen? I'm pointing between the two rectangular boxes toward the end of that window. See where it says Data View and Variable View. Here's how we start using SPSS. This is an example where we're not opening up an existing document, which you'll do with a lot of your analysis. We're just starting from scratch. We've got to enter data. To enter data, I'm going to Variable View. When I click there, it doesn't look much different. The column headings are a little different, but I've still got empty rows and empty columns. In the upper left that I just highlighted, the upper left blank box, I'm going to name my variable. In this case, with all the creativity I can muster, I'm going to call that variable X. So I'm going to type an X in this box. There it typed X. Now, the rest of that row is still blank, but there are some default values that you'll see as soon as I tell it to remember that X. And the way I tell it to remember that X is to get out of the window. Of course, when I get out of it, it says, okay, I'm through with you in there. So when I click out of the window, I'm going to see the default values for the rest of the rows. Now what that means, those are characteristics of the X. Under type, unless we tell it different, we're expecting a number. It's expecting a number. I can change the width, but unless I do that, it's expecting to be no more than 8 wide. I'm going to go out to 2 decimal places. I've not given any label or values. We'll talk about those things and the others as we go along. For right now, all I care is I've got a place for X. So if I had a Y, I would put a Y in my number 2 row, but I don't. We're going to soon, but right now I don't. So all I've done, I've just said, hey, we're talking about variable X. So in order to tell anything about the values of variable X, I have to go to data view. And watch what happens as soon as I click back on data view, that X is going to become my one and only column heading. The X is my column heading. Everything under that column or in that column is going to represent a value of X. And that column is the one, I'm going to use the same numbers I used a minute ago, so you can see I'm going to get the same values. I'm not lying to you this time. So under that column, I'm going to put and I've written down my numbers, 89. And I've got to go under that next. I can do it. Remember I said it was going to go 2 decimal places? Hey, there are the 2 decimal places. And underneath the 89 is going to be a 92. And the way I do this, I just use the down arrow rather than re-click and reaching for the mouse every time. So 92 is the next one. 89 is the one under that. Then a 93. And then an 87. Now, when you're finished, make sure you click off of that cell so it knows that you're finished with it. So I've got all of my values of X entered. So far, so good? No, not so good. What's happening? Did you put a space in? Let's see. Did you both get the same thing? Did you get that too, Allie? Oh, okay. You're on very. You need to go data. You need to go to data view. Now you go to data view. Say, yes. Right, because you told it you had some variables that you didn't name, but we're not going to do anything with it anyway, so it's okay. So all I care about right now is we've got an X in the left column. So are we all there now? Yay, hallelujah. Okay. Working for anybody at home? And again, I don't know who's using SPSS or not. Apparently what I wasn't clear about is when I went from variable view, I've got to go back to data view to be able to enter those values under the X. Okay. So now all I really care about is I want to show you how to get some characteristics about this distribution. So we're going to analyze this stuff and get at least the means and standard deviation. Actually, we're going to get a couple more things too, whether we ask for them or not, but we're going to specifically ask for means and standard deviation. So, in another step that's not rocket surgery, where do you suppose you would start going to analyze? I'm talking about the drop-down menus at the top, yeah. We're going to analyze. Where do you think? Sometimes it makes sense. Where do you think we're going to start when we're going to analyze something? I hear. How about we go to analyze? Yeah, above, that's right. When I click on Analyze, I'm going to get a drop-down menu. Now, you remember we talked about descriptive statistics? Means and standard deviations are descriptive statistics. So I'm going to go down, and I'm going to go to descriptive statistics. And I'm going to go, and there are a couple of ways we can get this information. The first way I'm going to show you, and this is the only one I care that you remember, really. I'm going to go to descriptives. Everybody with me, or at least see with me? Okay, pretty much when we analyze, we're going to start with analyze. We want, in this case, descriptive statistics, which includes means and standard deviations, and we go to descriptives. Now, as soon as I click on descriptives, I'm going to see a window open up with two boxes, a left box and a right box. You ready for me to do that? There's my left box and my right box. The left box shows every single variable we have, and we have a grand total of 1. So what we do, we pick from every variable we have in the left box, we move the ones to the right box that we want to deal with. You might have 50 variables, I only want to see something about 3 of them. In this case, I've got 1, that's the one I want to see. So I'm going to move the X to the right box. I can do this a couple of ways. I can either highlight and click the arrow, or you can just double click it if you're lazy like me. It'll move over there. Now, okay. I'm going to click on options, and that's going to give us some options. I've got some default things clicked here. Mean is already clicked. It's going to give me the mean because I could tell it not to if I wanted to. I could unclick it, but I want the mean. I also want the standard deviation. So it's going to give me the 2 things I really want, plus a few more things and a few more options. It's going to give me, by default, the minimum and maximum values. Hey, I think I'll ask for the variance and the range. I know what they are. Let's just ask for them anyway. So as soon as I decide what everything I want, don't worry about the distribution, the kurtosis, and skew. We do know what skewness is, but don't worry about that for what we're looking at right now. We'll talk about the standard error. That's what SE stands for. We'll talk about that later. And we want just things in. Well, there's no order doesn't mean much because we only got one thing anyway. So all we've got 6. So I'm ready to. After I've selected everything I want, I'm happy to continue. And then, as soon as I click OK, I'm going to get an output window. And it's going to give me all the information I've asked for. So it's going to open up a window, put it on top of this spreadsheet data view thing I have here, and give me the information. And one of the hardest things in SPSS is knowing where to find what you're looking for. So here's my output window. Doesn't show up very well, so I'm going to have to make it a little larger so we can see. In this case, we don't ask for a lot. But notice what we've got here. N is 5. The range is 6. Where do you suppose the range comes from? High is 93. Low is 87. The range is high minus low. The range is 6. The mean is 90, like we said. And the standard deviation, we said approximately 2.45. Sure enough, there's what rounds to 2.45. And remember what that number was before we took the square root? We called that the variance. Sure enough, the variance is 6. I don't want to use that formula. I want to press 3 or 4 buttons. Now, in your WHIT book, again, keep in mind that the WHIT book was written to be used without SPSS. So they crank out everything by hand. I like their examples, but I like the Green Falcon book because it uses SPSS, so we kind of put them together for this course. Okay, so any questions? At least kind of what SPSS looks like, sort of how you get started. We'll get used to this a lot more later, but I just kind of wanted to give you a demonstration. If you were able to follow along with your own, that's fine. If not, then we'll do that next time. But so there's how to use SPSS to get everything. It took us, 2+ hours and 45 minutes so far tonight to talk about this so far. So we've learned. It's taken us a little over about 3 hours to know how to do things quickly. That's okay. Any other questions, thoughts, comments?